Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from Method of Undetermined Coefficients. So let's get going. Problem: solve d square minus 2d into y equal to e power x sin x. We are given a differential equation d square minus 2d into y equal to e power x sin x. Okay, or we can write this as d square y minus 2dy equal to e power x sin x. We can write d square y as y double dash, right? Or d square y by dx square minus, we can write dy as dy by dx equal to e power x sin x. Or we can write this as y double dash minus 2y dash equal to e power x sin x. Okay, or y double dash minus 2y dash equal to e power x sin x. Consider it as equation 1. Okay, or both equations are same. Let's consider both equations as equation 1. Okay. Fine. Now we know that the solution to this equation is given by, the general solution is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral, and we'll find yc using the auxiliary equation, right? For that we'll use this form, which is in f of d into y equal to q of x form, where f of d equal to d square minus 2d. Right? The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d, right? Let's replace d by m so that we'll get f of m equal to m square minus 2m. Then the auxiliary equation becomes m square minus 2m equal to 0. Take m common from these two terms, we'll get m times m minus 2 equal to 0. Now equate each factor to 0, then you'll get m equal to 0 and 2, right? M equal to 0, m minus 1 equal to 0 gives m equal to 2. So m equal to 0, 2 are the real and distinct roots to this equation, right? Therefore m equal to 0 and 2 are the roots. So from this we'll find yc. Yc is given by c1 e power 0x plus c2 e power 2 into x, right? Equal to c1 plus c2 e power 2x. We know that e power 0x is 1, right? Since e power 0x is e power 0, e power 0 is 1. And we know that when two roots, say m1 and m2, are real and distinct, then yc will be one constant into e power 1 root into x plus another constant into e power another root into x. Using this, we wrote the complementary function to our problem. Therefore, yc equal to c1 plus c2 e power 2x. Now observe yc and q of x. We have q of x equal to e power x sin x and yc equal to c1 plus c2 e power 2x. So we have to observe whether yc and q of x contains common terms or not. In q of x we are having e power x sin x, and here you are having constant into x power 0 something, or e power 0 better, and e power 2x, right? We don't have any common terms in these two, right? Therefore q of x has no common term with yc, right? So we have to choose yp, right? Yp is such that it satisfies the given differential equation. So yp must contain q of x and all its derivatives. So before finding yp, let's find derivatives of q of x. We have q of x e power x sin x, right? Find its derivatives. Say, call it as t, say. Then t dash will be e power x, derivative of e power x into sin x plus e power x into derivative of sin x, which gives e power x sin x plus e power x into derivative of sin x is cos x. See, it contains e power x sin x, which is q of x. So if e power x sin x is q of x, its derivative contains e power x sin x and e power x cos x, right? So you'll get the finite set e power x sin x and e power x cos x. Okay, again you can check e power x cos x, derivative of e power x cos x is e power x into derivative of cos x is sin x, I mean minus sin x, plus e power x, derivative of e power x is e power x into cos x, which gives us minus e power x sin x plus e power x cos x, right? Okay. For e power x cos x, we got derivative e power sin x, e power x cos x, right? That means the finite set will be right. You'll get only two terms. One is e power x sin x, e power x cos x, irrespective of signs or constants. If you have, you can just neglect the signs and constants here. Just write try to express the derivatives in some finite set. Okay, so you have to pick yp from this finite set. Simply, e power x sin x is our q of x, right? So yp should contain e power 2x, I mean e power x sin x, that is q of x, and its derivatives, linearly independent derivatives, right? So I am writing q of x again. Now I'll find its derivative, that is e power x sin x plus e power x into derivative of sin x is cos x. Now I'll add up all this. I'll get 2 e power x sin x plus e power x cos x, right? Q of x, and this is derivative of q of x. So finally I'll sum up and obtain this, right? So using this, I'll write yp equal to, now you can just neglect the constants and write yp equal to a e power x sin x plus b e power x cos x. Okay, easy, right? So it is not necessary to blindly remember the formula. See, if you have any e power ax sin bx or e power ax cos bx, then yp must be e power ax, that is a naught e power ax sin bx plus a1 e power ax cos bx. It is a formula which we have to remember. Okay, instead of remembering the formula, just find q of x, pick q of x from the problem, write q of x and find its derivatives and sum up, and finally choose yp. Okay, irrespective of constants. Or simply you can just write some set form. You can write q of x and its derivatives in finite set form like this. So you have you have a term, yp should contain a term e power x sin x and e power x cos x. Okay, just forget about adding and all. Just by looking at q of x and its derivatives, we can say that yp should involve one term e power x sin x and e power x cos x. Okay, using a constants or undetermined coefficients, just write yp from this, or you can just use this formula. I wrote a instead of a0 and b instead of e1 here. Okay, so finally we got yp. Now I'll find yp dash and yp double dash, because we are having y double dash in the problem. We'll begin with yp dash. A into derivative of e power x sin x is derivative of e power x is e power x. I'll write it. Okay, you can just skip it, into derivative of the second term. This gives us a into e power x sin x plus e power x cos x plus b into e power x cos x plus e power x into minus sin x, right? Which gives us a e power x sin x plus a e power x cos x plus b e power x cos x minus b e power x sin x, right? Fine. Now find yp double dash. A into derivative of e power x into sin x plus e power x into derivative of sin x is cos x plus a into derivative of e power x is e power x cos x plus e power x into derivative of cos x is sin x, so you'll get minus e power x sin x plus b into derivative of e power x is e power x cos x plus e power x into derivative of cos x is minus sin x, so you'll get minus e power x sin x. Just find the derivative of b e power x cos x simply. Okay, minus b into derivative of e power x is e power x into sin x plus e power x into derivative of sin x is cos x. We'll get e power x cos x. Now from this we'll get yp double dash equal to a e power x sin x plus a e power x cos x plus a e power x cos x minus a e power x sin x plus b e power x cos x minus b e power x sin x minus b e power x sin x minus into plus minus b e power x cos x. Plus a e power x sin x minus a e power x sin x gets cancelled, and plus b e power x cos x minus b e power x cos x gets cancelled. From this we'll get yp double dash equal to a e power x cos x, a e power x cos x, 2a e power x cos x minus b e power x sin x minus b e power x sin x gives minus 2b e power x sin x. You got yp dash and yp double dash, right? We have yp equal to a e power x sin x plus b e power x cos x, and yp dash equal to a e power x sin x plus a e power x cos x plus b e power x cos x minus b e power x sin x, and yp double dash equal to 2a e power x cos x minus 2b e power x sin x, right? Now we can write the given equation as, We have picked yp such that it satisfies the equation, given equation, right? So we can write the given equation as yp double dash minus 2 yp dash equal to e power x sin x. Now substitute yp dash and yp double dash in it. We'll get 2a e power x cos x minus 2b e power x sin x minus 2 times yp dash, that is a e power x sin x plus a e power x cos x plus b e power x cos x minus b e power x sin x equal to RHS part e power x sin x, right? Which gives us 2a e power x cos x minus 2b e power x sin x minus 2a e power x sin x minus into plus minus 2a e power x cos x minus into plus minus 2b e power x cos x minus into minus plus 2b e power x sin x equal to e power x sin x. So here minus 2b e power x sin x plus 2b e power x sin x gets cancelled, and 2a e power x cos x minus 2a e power x cos x gets cancelled. It gives us minus 2a e power x sin x minus 2b e power x cos x equal to e power x sin x, or we can write this as e power x sin x, minus 2a into e power x sin x plus minus 2b into e power x cos x equal to e power x sin x. Now equate the equations of like terms. Okay, I'll equate the terms firstly. I'll begin with e power x sin x. We'll get minus 2a equal to 1. We'll get a equal to minus 1 by 2. And by equating equations of e power x cos x, we don't have any term in RHS, right? So we'll get 2b equal to minus 2b equal to 0. From this we'll get b equal to 0. Therefore, a equal to minus 1 by 2 and b equal to 0. We have yp equal to a e power x sin x plus b e power x. It's not 13b, it's b, okay? b e power x cos x. Substitute the values of a and b here. Then yp becomes minus 1 by 2 into e power x sin x plus 0 into e power x cos x, which is minus 1 by 2 e power x sin x plus 0, or you can write it as minus 1 by 2 into e power x sin x. Therefore, yp equal to minus 1 by 2 into e power x sin x, right? The general solution is given by y equal to yc, c1 plus c2 e power 2x minus 1 by 2 into e power x sin x is the required solution. See, we can verify yp using yp equal to 1 by f of d into the RHS part e power x sin x. you'll get the same thing. Just try it yourself. You can use this formula to verify YP. Okay, try it yourself. Well, we have seen a problem using the method of undetermined coefficients. I hope you'll understand. We'll see you in the next video. Until then, bye bye.